Hi to all. Now we are going to discuss force on moving charge in uniform electric and magnetic field. This force is also called as lorentz force. When a charge is placed in external electric field, it will experience the force. We know the formula for the electric force. And when the same charge, if it will move with certain velocity in the magnetic field, it will experiences the force. Okay, that is called as magnetic force. Then if the charge moves in electric and magnetic field, at that moment the two forces will act on that combined force is called as lorentz force. Lorentz is the name of the scientist. Now if the charge moves in the electric field, then electric force will be there, right? For example, electric force on charge, electric force on charge. What is the electric force on the charge? The electric force on charge formula is electric force F suffix E. F suffix E. Now, what is electric force? F suffix E. Electric force is equal to, we know electric field intensity formula. What is the electric field intensity formula? E is equal to, we know, F by Q. From this, electric force formula is electric field intensity into charge, we write F equal to EQ. Then I am writing the electric force on the charge. Okay, when the charge is in the electric field, it will experience the force. The electric force is equal to E into Q. Okay, but if you want to express in vector form, we write E bar, F bar. F suffix E, this one, that indicates electric force. Okay, and magnetic force on the charge. Magnetic force on charge. Magnetic force on charge. Okay, that is magnetic force can be denoted with FB. Its formula, we know already the magnetic force formula. In the last class we discussed, that is QVB sin theta. Okay, this is the in magnitude form. If you want to express in vector form, then we know the formula, that is Q into V bar cross B bar, right? V bar cross B bar. This is the force in vector form. Now I want to express in vector form, then we can write V bar cross B bar. Then this is the, when the charge moves in electric field, it experiences the electric force, and when the charge moves in the magnetic field, it experiences the magnetic force. Then if the charge simultaneously moves in electric and magnetic fields, then the two forces will act. Okay, force on charge in electric and magnetic fields, right? When the charge moves in the electric and magnetic field, then what is the force? Then that force we write as electric force, electric field. Due to the electric field, some force will be there on the charge. Electric force plus, and due to magnetic field, some force will act. It is a magnetic force. Then electric force formula is E bar into Q, and the magnetic force formula is Q into V bar cross B bar. Here Q is common, then we will get as E bar plus V bar cross B bar, right? This is the formula. Here we are getting, this is the net force on the charge in electric and magnetic fields. This force is called as, right? This force is called as what? Lorentz force. What is called? Lorentz force. Okay, right. This is the expression for the Lorentz force. What are the terms which are present in this? Okay, let us see. What is Q in this? Charge. What is E? Electric field intensity. Electric field intensity, right? What is V? Velocity of charge. Velocity of charge. What is B? Magnetic induction. Magnetic induction. Okay, this is about force on charge moving in Okay, electric and magnetic fields. Okay, in electric field force will be there, magnetic field force will be there. The total force is called as Lorentz force. Right, take the screenshot and note it. Now I will continue the topic. Okay, I will rub and continue the topic. Okay, look at here, our next topic is velocity selector. This is very important for the exam. Okay, it will be important for the 3 marks. Okay, very important. Let us see. Our topic is velocity selector. What is velocity selector? By using this velocity, we are going to derive one formula for the velocity selector. By using that formula, we can select certain velocity to a charge. You want to give certain velocities to the charge. That is useful for the experimental purpose. Okay, then for example, Rutherford alpha scattering experiment. In that, alpha particle is given to certain velocity, right? And like this, to give certain velocity to certain particle, we have to use the velocity selector. Now, how it will work? Let us see here. This is a Q charge. It is at the origin, that is moving towards the positive x-axis. For this charge, I applied the electric field along y-axis and the magnetic field along z-axis. Okay, consider the charge Q is moving with velocity v along x-axis, electric field applied along y-axis and magnetic field applied along z-axis. Then we know that already there are certain various forces will act on the charge. This charge is moving in electric and magnetic fields. That's why electric force will act and magnetic force also acts. What is the direction of the electric force and what is the magnitude of the electric force? Let us see. Okay, electric force. Electric force on charge. What is the formula for the electric force? Electric force F suffix E. Okay, F suffix E is equal to, electric force formula is been already we know EQ, but E is the electric field intensity. Okay, but what is the direction of the electric field? Electric field is applied along y-axis. To indicate the y-axis, we write the J cap. Okay, and the next one more force will act, the magnetic force. Magnetic force on charge. I want the magnetic force on the charge. What is the direction of the magnetic force? That is F suffix B. Its formula is Q into V bar cross B bar. V bar cross B bar. Okay? V bar cross B bar. But what is velocity V? V is along x-axis. Is it right? Velocity along x-axis. We write V bar as V I cap. Okay? And cross B bar, magnetic field is along z-axis. Then we write as B K cap. Here QVB we write outside. Then magnetic force we will get as QVB into I cap cross K cap we will get. But what is I cap cross K cap? You have to remember this cycle. I J K. I cap cross J cap K cap. Okay, I J K. J cap cross K cap. J cap cross K cap. I cap. K cap cross I cap. J cap. Look at here. I J K. J K I. K I J. I cross J K. J cross K I. K cross I J. Next we'll in clockwise, right? I J after we will get K. I cap cross J cap K cap. J cap cross K cap. Next one you will get K I cap. K cap cross I cap. Next one you will get J cap. If you want the reverse, J cap cross I cap. J cap cross I cap. You are going reverse. At that moment minus K cap you will get. Okay. Similarly here I cap cross K cap is there. What is I cap cross K cap? Here this is the K cap cross I cap is J cap. I cap cross K cap is reverse. Minus J cap it will gives. Okay. It will gives minus J cap. We write like this. Then the magnetic force we write as QVB into minus J cap we write. Okay, I cap cross K cap is minus J cap. This we write is minus QVB J cap we write. Okay, right. This here we got electric force. This is considered as equation 1. Okay. Here we got the magnetic force, right? Equation 2. And what is the net force on the charge? What is the direction of the electric force? Electric force will be along the electric field. Electric field is along y-axis, means electric force also along y-axis. Right? This is the electric force, F suffix E. What is the magnetic force direction? Magnetic force here we got minus J cap. Electric force plus J cap. Magnetic force minus J cap. Minus J cap indicates it is along the negative y-axis. Okay? Along the positive x-axis, positive y-axis, electric force will be there. Magnetic force is downward, electric force is upward. These forces are equal and opposite, right? And what is the net force at here? Net force on charge. Net force on charge. The net force we will get is F is equal, we have to add them. Right? Electric force plus magnetic force. Right? And now electric force is what? Electric force is, here we got EQJ. EQJ cap. Magnetic force is minus QVB J cap. Here the Q is common. We will get the one equation. QJ we can common. E minus VB J cap we will get, right? This is the net force formula. Net force we got is equation 3. Okay? Just these two forces you have to add, then you will get the net force. Just like Lorentz force only. Previously we discussed just now. Okay? Now, if the net force is 0, if the net force is 0, if the net force is 0, okay, E and VB, okay, what you have to do, then you have to adjust the E and B in such a way that when you adjust the E, electric force will changes. When you adjust the B, magnetic force will be changes. Then make the electric force and magnetic force are equal. Okay, when the charge moves in the electric and magnetic fields, two forces will act. One is electric force and other is magnetic force. When electric force and magnetic force are equal and opposite, then they will cancel with each other. Then the net force becomes 0. When the net force is 0, then the charge will continue in the same direction with the same velocity. Right? I am taking that. Then if the net force is 0, then we have to find out. Let us take the net force as 0. Okay? If the net force is 0, we write as Q into E minus VB J cap also becomes 0. Okay? Right. Then from this E minus VB is also 0. From this we will get E is equal to VB we will get. From this V formula we will get, right? V formula we will get is E by B. This V is called as velocity selector. Okay? And this is equation 4. And this V is called as, right here V is called as velocity selector. Okay? By changing the E and V values, you can give certain value, certain velocity. We can select certain velocity. That's why that is called as velocity selector. This was very simple. Okay? Note it and take the screenshot and note it.